All right. So first of all, if you remember previously, we learned few things about the Venn diagram. I will just quickly recall them so you don't have any problem later for solving this question. In Venn diagram, what we do, we take any shape. For example, if we take, uh, but mostly for the universal set, what we do, we take for the universal set always a rectangle, and within that rectangle, what do we do? We use circles. These circles are the representative of the sets. So if, for example, if you are having the two sets, let's say I have a set A and this is a set B. This area is the common area. I will say this is the overlapping area. In this area, we will write those elements which are common in both. Okay. Some notations that we use, you should know about these notations also. For example, if I say I'm going to write some elements in that one, I'm going to say that I have A, B, C, D, E, and F. It is like that. This is the universal set. Okay, this is the universal set we are having. So first of all, I'm writing a symbol. This symbol we use, we use it when we say is element or member of. For example, you can see inside the set A. If I write set A, what are the elements inside the set A? Mean that are coming within A, because we learned previously that if I write A, so A mean whatever is inside the A. So which elements are inside the A? Right now you can see these are A, B, C. I will say A, B, C. This is the set form. This is the Venn diagram form. Okay. Now if I have to write B, it means I will write whatever is within the B. Okay, what we are having within the B? We are having uh, C, D, and E. C, D, E. These are the elements within B. Okay, and F, if you can see, if I have to write the universal set here, what are the elements of the universal set here? It means whatever is coming inside this rectangle without repeating, you will write them. Like you will say, it means this is A, B, C, D, E, F. These are the elements of the universal set here in this Venn diagram. Okay, so this is mean if it is written in this form, you can write in this form, and if it is in this form, so you can write. Did you notice one thing? The C is in both. Yes, C is here, C is here. So I wrote it in the common region. It means if any element is coming in the common region, so we will write it here. And common region represent intersection. Okay, and previously we learned also how to shade. So in Venn diagram, shading I will use many times, that you have to remember. Secondly, this symbol is called member of or element of. For example, A, A is in this small a is in the set A, because set name we always give by the capital letters, that you have to remember. So this one A is inside the set A. You can see this element A is inside the A, so I can write A is element of set A or the member of set A. B is in A also, so I can say B is the member of A. Okay, so this symbol mean element of. C, I can say C is element of A. C is also element of B. Okay, because C you can see is element of both A and B. D I can say D is element of B. But if I say about A, I say set a relation between D and A. So you can see D is not the element of A. So I will say D is not the element of A. Okay. This symbol is for not element. This symbol is for element. This is element. This is not element. Another thing, if it's written like this way, N bracket A. It means number of elements in A. How many elements in number are in A? I can say 1, 2, 3. So I will write there are 3 elements in A. If I write like that, number of elements in B. So I will check inside the B. Inside the B, we are having C, D, E. Okay. So I will say how many these are 1, 2, 3. 3. But if just, for example, it is asked what is A, so then you have to write it in that form. But if this N is written, it means the number of elements in A. How many elements are in A? And if it is written in this way, mean the number of elements in B. Okay, clear? Hopefully you guys understand that. Number of elements in A, we will write it in this way. Number of elements in B, we will write it that way. But if I just say A, mean whatever is inside A. If I say B, whatever is inside the B. Okay, if that is clear, now let's move to the questions. And if anything that I miss, of course, I will explain there and then we will do the question as well. So with the name of Allah, let's start. Here we are having the first question. It's better if I zoom it a little bit so become more clear to you. Okay, this is the question here. You can see here, this symbol, this is for the universal set. Mean this is the universal set. Now this is set A. Notice one thing, inside A, we are having 3, 7. Inside B, we are having 7, 12. And outside of them is 5. First question is saying, the Venn diagram shows the number of elements in each region. Find the number of elements in A intersection B complement. If it is not visible, remember it's B complement, okay? So to find how many are in A intersection B complement, A intersection B complement. First, you need to, best way is shade it. Once you will shade, then you will have the idea which elements are there and how many total elements are there. Like 3 elements are there, 7 elements are there, 12 elements are there, 5 elements are here. So in this one, how many are? For example, if I check in within the A, in the A are 3 plus 7, total elements are 10. Yes. If I check in B are 12 plus 7, 19 elements are inside the B. So we have to find total number of elements inside this set. So first we will shade it. And for shading, I will highlight. Okay. For example, first A mean inside the A. Okay, shade inside the A. Okay, this is inside the A. Then I will let me shade it. If I need to remove, I will remove of course also. Okay, I shaded inside the A. Then B. Okay, inside the B. For inside the B, I will change the color. Okay, as I have to. Somewhere I can change the color. There was an option of changing the color also with me. That's why I'm not getting that one. Okay, anyhow, if I don't have, let's see, B complement. B complement mean outside the B. Okay, shade outside the B. Outside the B will be this one, this all. Now, which one? Because it is intersection, so you will only keep which one was shaded both time. So which region was shaded both time is this one, erase the remaining one. So if remaining one, if I will erase, it will be this one. Mean which is not shaded both time. The one that is not shaded 2 time, I have to erase and remain leave. So how many are left inside that one? If you notice now, this one is your A intersection B complement. So only 3 elements are inside that one. So I will say the number of elements because it is used n number of elements in this one. So 3 elements are there. So I will say 3 elements are there. Okay. So that is a very simple thing here. Understood? Please confirm that if it is clear. For part B, this is probability. Probability, of course, after that we will go. But probability is a complete topic. So we need to take that one. Then I will come to the probability. So for a while, leave it. No need to do right now here. Okay. I will try to remove this one before sharing with you so you don't get confused with that, inshallah. Clear? Okay, if this is clear, let me move now to the next one. Then again, this is also probability. An element is chosen at random, find the probability. And then to the next one. Yes, this one. On the Venn diagram, shade region A union B whole complement. For shading A union B whole complement, it's better if I draw my new region here. By the way, you have been asked that for this one, okay? But I will make the diagram here and will shade it. Okay, let's take this one set. Oh, the set is going to be bigger than this one. So then it's better increase the size of this one a little bit. Okay, one of the sets and another set, two overlapping sets. Set A, set B, because something is common in them already. A, B. Three elements were here, seven were here, 12 were here, and how many were taken here? Let me check that also. Five. Okay. So five elements were written here. That was, and this was your universal set. Now I have to shade A union B whole complement. And when I told you, whenever you have the whole complement, use De Morgan's law. De Morgan's law says that, right, this one, separate it. A complement, this union will change to intersection, and then this B complement. So now let's shade this one actually. A complement mean outside the A. Okay, the region outside the A. Okay, outside A region, if I will shade whatever is outside the A. Then B complement. B complement mean the region outside the B. Okay, for that I need another color. Okay, outside the B. Outside the B, everything color, but don't get inside the B, okay? That one. And you will just keep the one that was shaded both time. So it means this region was not shaded both time. This was not shaded both time. This was not shaded both time. So that will be. The other is shaded both time. So you have to keep that one. It means just keep this one and leave the other. So you shaded this one. This one don't highlight. Okay. There were three elements, seven elements, 12. So that you shaded A union B whole complement. That in our previous lesson we did in detail. We did the shading. So I told you, if you are good at shading, inshallah, doing the question will not be a problem at all. So just please confirm that. Is it clear? Understood? If understood, then I will move to the next question. All right, good. Okay, now next question is here. The set is the universal set, set P, set Q, and this is their description. Three elements here, five here, 10 here, and nine elements are here. Okay. These are actually the number of elements written in them. On the Venn diagram, show the number of elements in I said find the number of elements in P complement intersection Q. So it means to find the number of elements, if first shade P complement intersection Q. Because if you will shade that one, then you will be able to solve that easily. So first of all, P complement I will shade. P complement mean outside the P. Okay, shade outside the P. Okay, I shaded outside the P. Then Q, inside the Q I have to shade. So if I have to shade inside the Q, So, okay, let's see. Inside the queue will be this one. Okay. So which one, as it is intersection, so you have to erase the extra region. Just keep the one that was shaded both time. Erase the other. If I will erase other, it means I have to erase this one because it shaded just one time. Shaded just one time. So I will erase. Just I will keep the one that was shaded. I mean, this is your region. So how many elements are in this region? These are just 10 elements here. These 10. So you will see 10 elements are there. Okay. Then part B is saying that I will erase this one. So I will, for the next part, I will be able to. So if you know shading, then doing this one will be inshallah very easy. Part B is saying complete the statement. Number of elements 17. Write the set which will have total 17 elements. If you look at this one, 3, 5. So how we will have the 17 elements? Which set will have the 17 elements? If, for example, if I take all this one, it will have how you will deal with that 10 plus 15, 5 plus this will be 18. This will not be 17. Okay. Then, for example, 3 plus 5 make 8. 8 plus 9. 8 plus 9 are how many? 17. Yes. So for a while, I shade that one because if you take this one and all this, so total elements within that region are going to be 17. So what that set can be, first of all, you can see here, this is inside the A, then outside, sorry, it's not A, it is P, inside the P. Because you can see inside the P we took and outside of Q we took. And we did not erase anything outside of Q dash and their union. That will have the 17 elements. Because you can notice that I shaded this one, it make 8 and 9 are here 17. So inside P and outside of Q, I did not went in inside the Q because this region is shaded when I shaded for the inside, and after that I did not erase anything. When you don't erase anything, we put the union sign. So that is why it's P union Q dash. Okay. Again, I will repeat such question. For example, if any of the box is given here, and like let's say it's given that you are asked that, for example, what is this region? Like this is A, this is B. What is this region shaded? And along with that, all outside that one. So nothing is erased. It means you will say it's inside the B and outside the A, mean A complement and their union. So that actually is shaded. So similarly, we are looking for the 17 elements. For 17 elements, if we are looking here, so it will be that. Clear? Understood that one? Please make sure. Yes, please. Waiting for the response. If you understood, let me know. Okay, next question. Pretty easy. Actually, we did it already. But here we have to. The question is saying that shade the region required in the Venn diagram. I did the famous shading already with you, but just for recalling, so for better understanding, let's do it. First of all, this is a whole complement. For a whole complement, you will write it like that: a complement, because use the Morgan's law. It's a complement, union will change to intersection, B complement. Can you try to shade this one, please? And this one also. And let me know when you complete. I'm waiting, okay? Try to shade and let me know when you complete. You have a time of 2 minutes, okay?